Greetings and salutations, and welcome to the second video in our series called Linux Bash Shell Script Basics. In the first video, you learned what Bash was, what a Bash script was, how to write a Bash script, how to make it executable, how to test it, and where to put it on your machine to make it useful. At the end of that video, you had enough knowledge to be able to write a very simple script with one command after another, and those kinds of scripts can be very powerful. But in this video, we're going to talk about some of the underlying basics of the shell, some of the things that you can tap into to make your scripts more clever and run in a less linear fashion. We are heading in a direction where we're going from a simple script to more like a real computer program. So let's just jump right into it. The first thing that we want to talk about is standard in, standard out, and standard error, and what redirection is. Redirection in Linux is when you're executing a command, you can change where the input and output goes, the devices. Now we're talking about virtual devices in some cases, but a device would be anywhere that you would send input or output. The basic workflow of any command is just to take input from somewhere, do something to it, and then put it out as output. So the standard channels that we work with are standard input, known as standard in, and that's usually the keyboard. You just type. Standard out is usually the screen. And then we have another one called standard error, which is just for error messages. And the reason why it's done that way is because sometimes the output from a command is being sent into a file or into another command. And in that case, we won't see it on the screen if our error message is mixed in with that. So having another channel just for error messages means that we can see if an error happens and the command can still run. So that's just something to keep in mind when you get to a point when you start writing scripts that are sophisticated enough to have error messages in them. With redirection, the above standard input-output can be changed. The first thing that you can do is use a pipe to send output into a program, and I have an example up there. We're gonna actually run that and see how it works. So we're going to use ls, and we're going to do the long option on ls, and let us work with let's do documents in my home directory. There's a lot of stuff in there, right? So if I just turn this loose like this, you notice it runs off the screen. I mean, we have a whole list that goes up here. Well, it would be a lot easier if we piped this into less, which is a pager. And then with less, you can just go up one line at a time if you want to, and exit out, and you're done. So that's one way to redirect output. The other way to do it is to send it into a file. And to do that, we use that little redirection character right there, which is just saying, hey, I want you to send this output into where I tell you to send it. And we're going to call it ls output. And we'll be all formal and put .txt on the end. How's that? So now we're going to run that command, and you notice we didn't get anything on the screen. That's because everything went in there. So let's use less once again to open up that particular file. And you'll see that we have a whole bunch of stuff in here. It's all the crap that's in my document directory. So clear the screen. Q to get out of less, and then clear the screen. So another thing that we can do is we can run the same command, and this time we can throw the output away. And you do it exactly the same way, but this time we're going to send it to a special virtual device on the machine called dev null. And dev null is the bit bucket. It's the trash can in the system. Any output from any command that you don't want to appear on the screen or go some other place, you send here. And you might be thinking to yourself, why is that useful? Well, sometimes you run a command only to get its exit status. Sometimes you run a command only to perform some function, and you don't care about its output, and you don't want it to go, let's say, into a system email, which will end in the root users, end up in the root user's directory or someplace like that. And that can happen when you're doing like cron jobs and things like that. So that's what devnull does. It allows you to just send any unwanted crap that you don't want to go somewhere into the bit bucket, and it absolutely disappears. So let's jump back up here and see if there's anything else that we need to add to that. Well, I do want to add here that you'll notice at the end of this example right here that you have this little set of stuff here where we have an extra redirect. So it says 2 is redirected into 1 there. Well, what that means is that devnull will catch error messages from the command that's running in front of it as well. In other words, everything's going to go into the bit bucket. And that's important to understand when you're really wanting to get rid of all of the output. So you can send an error message to standard error, and it looks like this. Of course, if you run this command on the screen, what you're going to get, let's see, we'll just do that. Just to prove, really, drive a point home here. Let's go ahead and put that in there. You'll see that it comes up and it says this is an error message. You're still seeing it on the screen. That's because the second channel, the standard error channel, still shows on the screen. But you can also redirect standard error into a file. Let's say if you have a log, you're trying to catch errors, that sort of thing. Very flexible when you're dealing with that. So that's the basics of standard input and output. And it's something that makes Unix-like systems, which is what Linux is, extremely powerful, because we can take a lot of really small tools and we can daisy chain them together to do very powerful things, and that is called the Unix way. And Linux is a system that is a Unix work-alike, so in Linux we talk a lot about the Unix way as well. Moving on now, next concept we're going to deal with is variables. A variable is a character string, which basically just means it's some sort of data. It can be anything. It can be a number, it can be text, a file name, it can be a device location. It doesn't even matter what it is. The output of a command, any kind of data can be put into a variable. And the variables are extremely useful. So when your system boots up and you open up a terminal, there are all of these variables that are already set. And they're sitting in memory, ready to rock and roll, and you can get a hold of them. And that's the first thing that I'm going to show you is the memories. Let's go ahead and clear this screen. And what's in the memory in a standard environment, okay? So when your system boots up, there's all these configuration files that it goes through, and it sets these variables. This is what it looks like. Now, right now, it might not look like that this is a bunch of useful information, but if you start kind of scrolling through the list here, you see we got some really useful stuff. Let's see here. There's my home directory right there under a variable that's simply called home. So we can scroll down through here. My username is in here as well. We have a login name, which is kind of the same thing but a little bit different. Here's the path statement that we talked about in the first video right there. So that is in a variable that's sitting in the system. So you have all kinds of really cool little bits of information that you can grab. Now, what makes this useful is that here's where we're starting to get into the concept of portability when it comes to scripts. So if I want to write a script that runs on my machine and I have to access my home directory, I could write the script where I would put a direct path to my absolute path to my home directory in there, which would be /homejoe, whatever. Problem is that if I give that script to you and you try and run it on your system, that doesn't work unless your username happens to be Joe, right? We can use the variable in this situation to match any user anywhere, because standard bash is that variable will be whatever username is running it. So that's what shell variables are all about. And there's a whole bunch of them to work with. We can set variables quite easy. It's just silly easy to do. So let's set a variable right now, and it's A equals B. Here's our variable. Our variable is set. If you want to see what's in a variable, no problem whatsoever. We use the echo command. Variables always start with a $, And we're going to look in what's in variable A. And you see that we have that information that we put in there called B. You want to get rid of a variable, we can unset a variable. And just unset this variable, which is going to be A. Alright, so if we run this command again, we were supposed to unset that. There we go. So we don't need the dollar sign there. See, and if I would have looked at my own notes, I wouldn't have made that error. But nobody's perfect. Let's see here. What else do we need to talk about with variables? I used this particular example right there when I was putting that together. So you've seen pretty much everything there is to see about variables, but then we have some special variables that we need to talk about, and these are a little harder to demonstrate, so we won't be demonstrating them, but what we will do is we'll talk about them here looking at the you'll see this in action in scripts later, but I can't show it to you that easily in a terminal. Let's put it that way. So any input a user adds after a command is placed in a special variable called arguments. And the arguments are whatever you type in, and they're separated by a space. So when you type a command in there, which is a string of data, you have the command name, which would be the first one, and then you would have the arguments after that. So argument 1 would be the first file, argument 2 would be file 2, and file 3. Also, it works with options. So if you were trying to get an option out of something and you put it in there, there's your argument right there. So these variables are set up every time you fire off a command in the system. And you use this within your own script to be able to figure out what users put in to access different options. And we're just going to stick that little feather in our cap. We'll see how that works later on in the series, and it'll make more sense later. There's a special shell variable that is the @ sign, and it represents all of the arguments in order from 0 on up. So you could have 10 if you wanted to. And what this does is it allows you to access those arguments in an order. For instance, you may have a loop command of some sort. You want to do something for each thing that a user puts in, let's say their file names or something like that. Well, that's how you would access that. So when you have all this information that you can stick into variables, now we get into doing something very useful, and that is tests. And tests are how we make clever scripts that know what's going on as they're executing. They know what's going on with the system or what the user has put into the system. There is a million ways to use tests, and they very often go along with variables, what we want, or arguments actually too. What we want to do is just check to see if a piece of information is there. Tests can also be used to see if files exist. So let's go ahead and look at a simple test command. We're going to use our variable again. So what we're going to do is we're going to go ahead and do our original deal there where we created a variable, A equals B. And we're going to test to see if that's true. So the command would be test. And then we want to test this variable. So we want to make sure that A is equal to, 2 equals in a row there for this syntax. Put this in quotes. B is what we're looking for. And now, when we run this, we're not going to get any output. I mean, if I just run, you're not seeing anything on the screen. So what we're going to do is use a trick. We're going to use the exit code, which is another kind of variable that is set. Every time a command is run on the system, it creates an exit code. If the exit code is 0, that means everything's hunky-dory. It ran all right. If the exit code is anything other than 0, 1, or any other number, that means that there was an error of some sort, or it didn't work the way it was supposed to. So you've seen commands where you have the double ampersands, right? What am I doing? There it is. My finger just wouldn't go the right way. Well, you probably wondered why that's done that way. Well, basically, what double ampersand means in the shell is that we're going to run 2 commands side, one after the other. And if the first command runs successfully, then we'll run the second command. So we can use that in a test like this. So what we're basically going to say here is, yep. Okay? So if the test is, does this variable equal B? Here we go. Yep, it works. Now, we can also have an else in this. Put two pipes in a row there, and that basically tells the system, okay, if the command in front of this didn't run properly, if it throws an error and puts something in the exit code, then guess what? So let's demonstrate this. It's going to do it it's going to do the opposite thing, which is what I was trying to say. So for this one, we're going to echo, nope. All right. So this is our echo. So let's go and change our test. Let's make this equal A. Of course, we could change the variable at this point too. We could do anything to make this do this, but here we go. See? That is a basic test using the test command right there. Now, you can also do an opposite, where we're going to tell it, okay, we're testing to see if this variable is not A. Wonder what's going to happen. Yep. See, we changed it. We put it on its ear. Now we're looking to see if it's not there. And we get a different result. So that's how basic tests work. Now, we come up here, and the basic tests are really quite useful. So here is the format that we were just using there, and we can actually let's go ahead and put this one in place. And this is testing for a file. So let's go ahead and just copy this one and clear the screen there, please. And see, let's see, did that run? What did that do? Yep, there you go. So now you get some idea of how this works. Bash RC is not there. Why? Because we're not in the home directory. So if I do this, and I run exactly the same command, watch. Bash RC is here. There you go. Pretty cool, huh? Now, one of my favorite little snippets of code ever is this thing right here, and I use it all the time. And it's basically we're testing again. So what's going on is that we are listing what is in the package base for our Ubuntu or Debian system right there. That's that one command. dpkg L lists all of the installed packages. We send the output into the grep command. What the grep command does is it looks for whatever string of data you tell it to look for. And in this case, we're telling it to look for this and do it quietly. We're not going to put anything on the screen at all. And we're looking for ffmpeg, which is our package, right? So if that does not exist, then you're going to get an error code that goes into the variable for the error. And since it didn't run, if it threw the error code, you get this double pipe right here, sudo apt install, and then this tells it to do it anyway and do it very quietly, and it grabs the ffmpeg package. One thing I have not shown you is that variable, so let's do that so I make sure that you've seen what I'm talking about. Where does the exit code go? Well, it goes into a variable called question mark. It's all it is. So the last command that ran properly. So I can do this. Let's do the which command and then just make up some weird thing that doesn't exist. Okay, it's not there, right? Now we get an exit code of 1. Some programs have special exit codes. They're error codes that you can look at the documentation, and it says, if you've got a code 255, it'll tell you what went wrong and where it went wrong in the code. That's usually for really deep development stuff, and most regular users aren't going to run across that for sure. So, let's go up this way. I'm not done yet. I got more stuff to talk about. We'll do that at the end, okay? All right. So I've shown you how the testing works, and I have some examples here. And this is an if statement. Now, an if statement is a little bit more of an advanced way to do a test. The actual test command here is this set of brackets that you see right here. Right here, that's another way of writing out the test command. We get the output of that, and essentially, if the syntax goes like this: if we test for something and it's there, then we will do this. And you run some commands. But if it's not there, or if the test fails, then we will do this, and then the little token down here, fi, tells the system we're out of that if statement. The else is optional. You can have if statements that basically don't work unless whatever they're testing for matches up to however you want it to be. Whether, let's say for instance, you're testing to see whether a file is there or if it's not there. If the file is not there, then we have to halt the script because it doesn't have something it needs to work with. So that's how those tests work. And then here I go into how you can use tests if to test for errors. Now here's a really good example here. This is from a script that I have. We're looking for the ifconfig utility. So let's just talk about how this one runs here. So we're using the which command to look for ifconfig, and we're taking the output from that, whatever that is, and throwing it into dev null. Because if it finds it, it's going to give you a path where it exists. We don't really want that information printed on the screen. What we're interested in is the exit code. So then we test for the exit code. See, if that variable equals 0, does not equal 0. Actually, that's the way I wrote this. It can go either way. You can have it where it tests to see if something is there or whether something isn't there. But if it doesn't equal 0, then it throws an error. Sync all, the ifconfig utility is not installed. And you see that we're taking this error message and we're putting it in error 2. And then we are exiting the script without executing anything else, and we have an exit code on the end of 1, which means that our script will exit with an error code that will go into the variable that is the $? That's how that works. So the next thing that I want to get into in this video is talking about functions. We're going to talk about setting up an advanced script, and I'm going to just show you some examples of how this works. We'll look at some scripts that I already have that are done this way, and this is kind of a teaser concept because there's a lot more that goes into how functions work. But you take all of this testing and then you're able to grab options. And when you get those options, then you can have a script that instead of runs linearly from the top down, one thing right after another, now you can load a bunch of functions into memory. These are like miniature scripts. They're like commands that you create within a script. And then you can run those in any order you like. So an advanced script would look something like this. We have, first we start out with our shebang up at the top, and we have our comments here. This is an example script. And then we would declare variables. This would be any variable that you'd need to declare at the beginning. Usually what I do in this space here is to grab variables from the shell. So for instance, if one of the variables that my script uses is username, sometimes I'll go ahead and grab those and then I'll make them a local variable to the script. It makes it a little bit more robust when the script runs. Sometimes you'll run into strange problems with variables. You'll create a command, you'll have your variable in there, it looks the way it's supposed to be, and for some reason the script acts like it isn't there or doesn't run properly. So what I find is that if you grab a shell variable and then you put it in a local variable like that, then it's going to run better. So the next thing that we would do would be functions, and there's two separate syntaxes for functions. This is the one that I use. There is another one that's better. So you start out with the name of your function. In this case, I've called this function 1, and you get two little parentheses right there, and then you have a curly Q bracket. And everything in here are the commands that you're going to run in that function. And then at the end of this is what the end is. And all of this information right here is put into memory. And now you can call these functions just like commands within the script. So one of the first things here that I have demonstrated is that within a function you can create variables that only exist within the function. These are not global shell variables. Up to this point we are creating a variable for the shell environment that we're working in. So you have the global shell variables, then we're creating variables within our script. They exist while the script is running, and then within that script we can have variables that are assigned only to the function. So when that function stops running, we get out of it and we move to something else, that variable is not being looked at. And that can be a very useful little tool. The end of a function, you have the return command. The return command is similar to exit, but instead of exiting the entire script when you use the return command, what you do is you go back to the environment that the script is running in. This is very useful for error statements within a function, or for some reason you need to stop a function halfway through execution. You don't want to completely leave the program. What you want to do is you want to go back to something else, and that's what that's for. And you can have a return code, exit code as well, but most people who are writing the scripts that we're kind of talking about, we don't really need to get that deep into it unless we're doing something, really huge. So I'm not going to talk much about return exit values. And you see we have another function down here. We can set more local variables in here. And now if for some reason we have an error code within a function, we can exit and use the exit code 1. That basically says this script screwed up, and it's putting an error exit code into the question mark shell variable there. So once you declare your commands, we've grabbed our variables up here at the top. We declare our commands, or our functions, and our variables. We're just loading all this crap into memory, basically. Now we get down toward the bottom of the script, and then we're going to do execution. So that order is very important because you can't run a function that isn't in memory yet. So you can't be calling on a function somewhere up here at the top of the script and you haven't loaded it yet. The system will go, there's an error, I don't know what you're talking about, because it loads from top to bottom. So in execution, the first thing we usually do is test for the options, and then we use commands to call functions. So what we can do now is we could call function 1 and then function 2, and then we could say exit if we wanted to, and there you go. Probably be a little bit easier at this point if we actually look at a script that works that way. So let's go ahead and wrap this video up by looking at a script like that. So we are going to use nano because it's just pretty to look at, and we're going to look at, let's see, where am I at? Documents, right? Scripts, right? We got to get projects, yep. And we want to look at up, yep. And we want to look it up because that's the name of the script, right? Now I wrote this script a while back to demonstrate functions, basically, but it has become a tool that I use every day, and just recently posted a video where I did some small updates to it. So here you go. We don't have any variables in up because we don't need it, but we do have this extra command right here. See this set E? Now that's a unique command. It's very useful in certain scripts, and what it does is it basically tells the shell while this script is running, if there's any error at all, just stop working. You don't need an exit code, nothing. Just if you get an exit code of from any command that's running within this error of 1 or anything else, in other words, a bad exit code from anywhere, just dump the thing and move on. And I did that because this is handling updates. So the first function you see has some pretty simple commands in it. The first function here that we're working with is called update, and it echoes that we're starting a full system update, and then it does sudo apt update and then sudo apt dist upgrade, which should be pretty familiar commands for folks who use Debian and Ubuntu. And I have been informed that with apt, this dist upgrade should actually be full upgrade, but dist upgrade seems to work, so I'm leaving it be for the time being. So that's our first function, which is a basic update. Our second function is going to be a cleanup. Now the cleanup function is going to be sudo apt auto remove, and then we have sudo apt auto clean. What the auto clean function does is it goes into the apt cache, which is in var. That is where the packages that you have installed on your system have backups, and it removes anything that for some reason you can't actually install again. Sometimes that happens and you get those orphaned packages left behind. That's not the same as auto remove. What auto remove does is it removes programs that you no longer need and libraries that are installed on the system that are now not being depended on by anything else. So they're not like full-fledged system programs where you can interact with them, but they're components that other programs need. Sometimes they get left behind when something gets uninstalled. So that's the cleanup function. Now I must explain what the YY is about, because people ask. The reason why the YY is there is that in older documentation for the apt and apt-get utilities, it says that if you put a YY, that it will pretty much ignore any on-screen prompt, and it will just run the thing. And so the first Y says yes, run it, and the second Y is like, really, yes, run it. So that's what that does. So we have a function called update, we have a function called clean, and now we have a function called leave. And in there you will see that we have pretty simple stuff. It's just me echoing this nice little bit of ASCII art that says update complete. And then just using 3 lines. It's a pretty simple way to do that. We're going to look at a more sophisticated way to put stuff like that on the screen in the next video. And then we have an exit here, and if there's no number next to the exit, then that means that it's going to exit with 0. It means that's what we want it to do. When the script is done, it's going to leave an exit code of 0. Now the next function that we have is called uphelp, and here's a situation where we're using a more sophisticated way to print stuff on the screen, and we're going to get into more of that. We're using what is called a here document to do this, and it's basically taking this text and sending it into the cat command, and it will send all the text from here all the way down to where it says EOF right there. That's the token for the end of that. And that is in a function. So when the script runs, all of this stuff that we've just looked at is loaded into memory. Now we get to the execution section. And I have this thing here, tell them who we are, which kind of just tells you what this thing does. And I didn't do that when I did the P2V script because FFmpeg, scrolls so much stuff up the screen that you never really get to see it. So I didn't bother with the tell them who we are. That's something I've done in scripts for a long time. So then we're going to do the update and clean. And we are testing argument 1, right there, do you see that? For the option clean. And if that's the case, then I say, okay, run these commands, run these functions as commands here. So it runs update, clean, and then it leaves. And that is in an if statement. So if you didn't put clean in there, the if statement just skips. It just keeps going because it didn't match the criteria. It doesn't actually run the commands. So if you typed in up and then you put as the first argument this, now we run the part of the function that we just looked at called uphelp. And that's what it does. And it exits the script. Bye, see you later. So if you want to run it again, you have to put something else in. Now, this is check for an invalid argument. This would be, this is putting anything else in other than hyphen clean or hyphen help right here. So this is what we're testing for. This is what this command does. It says basically if there's anything in the argument by this point, since it didn't test here, didn't say trip this, didn't trip this, and we have some gobbledygook in there, just somebody mistyped something or whatever, then what it's going to do right there is it's going to say, hey, you put some garbage in here and I don't know what to do with this. So that's why we get that error message. And that error message is being sent, I believe, to the error channel, but what you're seeing here is that we have to go over to look, because this is what Nano does. That's how it continues a line. So there it is right there. And then finally, if you don't put any argument in at all and there's nothing in there, then it comes down here where it just runs a regular update and then it runs leave. So that's how that script works. And you have been shown all of the concepts that go into the making of this script. So now you should understand exactly how it works and what it does. This information is going to be in the description for this video, and you can link over to that. I'm going to post that on the news section of the EzeeLinux site. Your feedback is always welcome, and I got some really nice feedback from part 1, so thank you very much. Now, in part 3, we're going to take a look at here documents. We're going to touch on menus, and I haven't quite decided what else we're going to talk about in there. I got to go off and do a little bit of research myself to see what concepts we'll jump into the next time around. As I said, as we get further into this, it's going to be a little bit more non-linear. So check out EzeeLinux.com for more about Linux. Also, join the discussion at EzeeTalk. It's free, secure, and fun. It's a forum that we run ourselves. We control it from the server on down. Please be sure to give EzeeLinux a like on Facebook if you are a Facebook user. And of course, if you like the video, give it a like as well. Certainly do appreciate it. Looking forward to part 3 coming up soon. Thanks for watching.